compounded interest, and other applications. We'll make the calculator small here. Compounded interest is what happens when you earn interest on not only the money that you deposit in an account, but you also earn interest on the interest that you've already earned. The formula to find the amount in the account when interest is compounded is the principal, which is P, times 1 plus R over N, raised to the N times T power. Here's N is the number of times each year that the interest is compounded. R is the interest rate. And your T is the number of years. So let's take an example of depositing $2,000 in an account that's going to pay an annual interest rate of 6% for 30 years. Now this is going to be compounded every year. So A is equal to P times 1 plus R over N raised to the NT power. Now here our principal is our $2,000 that we're depositing. The interest rate is 6%. And we want to use the decimal form of that 6%. You also could use the fraction form, but for the most part, the decimal form is easier to put in your calculator. So R will be 0.06. The number of times each year it's compounded is 1 because it's going to be compounded at the end of each year. The number of years we're going to keep it in is the T. So T is 30. So A will equal 2,000 times 1 plus 0.06 divided by 1 raised to the 30 times 1 power. Now you don't want to jump in and just put this all in your calculator all at once. So let's do a little bit of simplifying here if we can. This divided by 1 is just 0.06. So 1 plus 0.06 is 1.06. 30 times 1 is the 30th power. So I need to put this in my calculator to find my value. We'll put some in that are a little more complicated in a minute. So this is just going to be 2,000 times 1.06 raised to the 30th power. At the end of the 30 years, this will be $11,486.98. Remember that when you're talking about money, you want to round it off to the nearest cent unless you're told to round it some other way. Now that was compounded once a year. Let's take the same deposit, same interest rate, and this time we're going to compound it quarterly. Quarterly means that the number of times each year it's compounded is going to be 4. We're still going to use an R of 0.06, a principal of 2,000, and a T of 30. So this time, it becomes a little more complicated. I will have 1 plus 0.06 divided by 4 raised to the 4 times 30 power. Now I know that power is 120. So I'm actually just going to go ahead and multiply that together to be 120. Now, in order to put this in your calculator, I think what's easiest to do is to start here with your parentheses. Remember, order of operations, you always want to do that first anyway. So let's put this in our calculator first. I can do, let me clear that out, parentheses, 1 plus 0.06 divided by 4, close the parentheses, and then raise it to the 120th power. Now, I like to get that answer and then multiply that times the principal. So this time, I got a little bit more interest. $11,938.65 is what that would round off to. So compounding it more often ended up giving me a little bit larger balance. Now let's look at another problem. This time we're going to compound it monthly. So the only thing that's going to be different here is the n is going to be 12. So let me take the same formula. Oops, this is r over n raised to the nt power. So this is 2,000 times 1 plus same interest rate of 0.06, but this time the n is 12. So my exponent here is going to be 12 times 30. So I have 2,000 times 1 plus 0.06 over 12 raised to the 360th power. So now I need my calculator. And I want to put in parentheses 1 plus 0.06 divided by 12, close the parentheses, and raise it to the, you can do 360 because we know our 12 times 30 is 360. Now I want to multiply that by your 2,000. So this gives us, again, a little bit more money. We compounded the interest more often, so the money grew a little faster. $12,045.15. Now, I also could have put this in all in one step. You just have to be a lot more careful doing it that way. I prefer to do it in 2 steps. I get the same answer. Now let's take a look at what happens if the interest is compounded continuously. Here it says interest is compounded continuously. Here our formula is a little simpler. It's just principal times e to the RT power. We don't have to worry about the n's. All we need is the principal, the rate, and the time. So here, the principal is still $2,000. That'll be times e to the r is 0.06, and the time is still 30 years. So putting that in my calculator, I get 2,000 times e. Then I want to put 0.06 times 30 in the exponent. So it has to be in the parentheses there. So this time, it still grew a little bit faster, and I got a little bit more money. $12,099.29.